Hey YouTube, welcome to the next episode on differentiation. Today we're going to look at tangents and normals. This follows on quite nicely from our last episode on differentiating the power functions. So let's get right to it. Now, what do we mean by a tangent to a curve? Well, what we explored in our first lesson is that the gradient of a curve at any given point is equal to the gradient of the tangent at that same point. So in this first question, it says find an equation of the tangent to the curve y equals x minus 2x at the point 9, 3. Well, with any line, we need to know its gradient. But we know the gradient of that tangent is going to be the same as the gradient of the curve at the point 9, 3. So all we do is we find the gradient of this function by differentiating. We know finding the gradient, the link is to differentiate, or the connection that we should make there. The first thing we need to do is we need to rewrite root x as x to the power half as a power function. Then we're going to differentiate. X is a line with gradient 1, so x differentiates to 1. Here we're going to bring down the half. Minus 2 times the half is minus 1. So we get negative, I'm not going to write the 1, but x minus 1 for the power. Then we're going to sub in 9. Subbing in 9, we get 1 minus 9 to the power of minus a half. 9 to the power of minus a half is 1/3. 1 minus 1/3 is 2/3. Then we just do y minus y1. So we're going to do y minus 3 is the gradient, x minus the x coordinate of 9. Get rid of denominators, move everything over. And that's our equation of the tangent. How does it work with normals? Now, we know from straight line graphs, we did that together, when we have a curve and a tangent. So a tangent has the same gradient. A normal will be perpendicular. So all we do is the exact same thing. The only difference is at this step, once we found the gradient, we do the negative reciprocal. So step 1, we're going to find the equation of the normal to this quadratic at x is minus 1. We're going to first differentiate to find the general gradient. X squared differentiates to 2x, minus 3x differentiates to minus 3. Then 4, remember 4 is a horizontal line with 0 gradient, so constants disappear. So subbing in minus 1, we get 2 times minus 1 minus 3, which is minus 2 minus 3, which is minus 5. So the normal gradient, the normal, will be the negative reciprocal of that, which is 1/5. We can now use y minus y1. The only thing that's missing is the y coordinate. So we're going to find the y coordinate at minus 1. So we've got 1 plus 3 plus 4, which is 8, sorry. So y minus the y coordinate is the gradient of the normal, which is 1/5, x minus the x coordinate, which is minus 1. So it becomes plus 1, times through by 5, and then we move everything over. So we get 5y minus x minus 41 is 0, and that's our normal. Hey guys, I hope you're enjoying the video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button and comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Next question, the diagram shows the curve with the equation y equals x cubed minus 2x squared minus 5x plus 5. The straight line L is a tangent to the curve at the point P minus 1, 7. The straight line M is parallel to L and is a tangent to the curve at the point Q. Okay, so this is the line L and this is the line M. Find an equation of M. All right, so M is parallel to L and L is a tangent to the curve at the point P. So what we need to do is find the gradient of L. M is going to have that exact same gradient. So we need to differentiate first. dy by dx is 3x squared minus 4x, bringing down the 2. Then minus 5x differentiates to minus 5, and then the plus 5 at the end just disappears. Now we need to substitute in minus 1. The x value here is minus 1. And what does that give us? That gives us 3 plus 4 is 7, minus 5 is 2. So the gradient of L is 2, which means the gradient of M is 2. The only thing we don't have about M is that, well, whatever the coordinates of Q are. So we need to somehow use this gradient of 2 to find out what Q is. Well, all we do is we know that dy by dx is 2. We're going to sub it back in here and find out what the other x coordinate is. So subbing in 2 here, move the 2 over. Now we already know how this factorizes. The reason for that is we already know the coordinate of p. The coordinate of p is x is minus 1, which must mean that the bracket must be x plus 1. P must be a solution to the gradient being 2, right? So what must the other bracket be? It has to be 3x. Then 1 times something is minus 7. That'll be minus 7. So the x coordinate of q is 7 over 3. All we need to do is find the y coordinate of q. So for that, we're just going to take 7 over 3 and substitute it into y equals x cubed. The easiest way to do this is take 7 over 3. Let's store it as a. Then we'll do a cubed minus 2a squared minus 5a plus 5. So we get minus 131 over 27. So doing y minus y1, y plus 131 over 27 is the gradient of 2x minus 7 over 3. Now for this, I'm just going to rearrange for y. I'm not going to get rid of denominators here. I'm just going to utilize the calculator. So we get 2x minus 14 over 3. And then we subtract this over. All right. Find an equation of the normal to the curve at P. So at P, we need to find the normal. The normal is just a perpendicular gradient. So what's the gradient at P going to be? Well, we know that the gradient is 2. So the normal is going to have a negative reciprocal gradient. So then we're going to do y minus y1. Y minus the y coordinate of P is 7 is the gradient. X minus the x coordinate becomes x plus 1. And then we can expand, or this times through by 2 here. Move everything over. So there's our normal. Hence or otherwise, find the distance between the lines L and M. All right, so the reason they've asked us to find the normal is if we keep going, keep drawing it, because M has the same gradient as L, this normal is perpendicular to both. So if we want the shortest distance between the two lines, all we need to know is we have P here. We need to find what the other side would be. So the question comes, how do you find this other side? Well, to do that, we need to do simultaneous equations. We need to find where the line M meets the normal. So we're going to do simultaneous equations with this and this. So I've already rearranged for y. I'm going to substitute that in. So we get 2 lots of 2x minus 257 over 27 plus x minus 13 equals 0. Now I'm going to expand and I'm going to rearrange for x. So we get x equals, so we're going to do 865 over 27 divided by 5, which is 173 over 27. And then we're going to take that value and we're just going to sub into one of them to find out what y is. 89 over 27. Now that's the coordinate on the other side of the graph. The last thing we need to do is find the distance between those two coordinates. Well, for that, if I just call it d, the distance d is we just do Pythagoras after subtracting the coordinates. So I'm just going to do it all in one step. So we're going to do the x coordinates taking away. So minus 1 minus that 173 over 27 squared plus the subtraction of the y coordinates, 7 minus 89 over 27 squared. And let's see what that gives us for d, which gives us approximately 8.28 to 3SF. And this is how you answer a cool question like this involving tangents and normals. Okay, so that's it, guys. This is me showing you how to do tangents and normals and applying it to what would be regarded as quite a difficult exam question. So stay tuned for the next episode where we're going to continue on with differentiation. If you learned something, please hit that like button and subscribe if you want more maths content. I look forward to seeing you guys in my next video. Peace.